Alright, so we're going to start a new section. It's called literal equations. So we're still solving equations like we always have, but these are just look different. So we're going to solve them not just for x, we're going to have variables in our answer. Okay? So if you see this example, the example is 5a plus c equals negative a, 8a. And they ask us to solve for a. So just like before, my first thing is I need to get all my a values to the same side. Since I already have the negative 8a over here, and there's nothing else by it, I'm going to go ahead and move my 5a over. To move my 5a over, same rules apply. I'm going to subtract 5a from both sides of the equation. Now again, you can draw that wall that your middle school teachers taught you about. Now, I have left a c over here is equal to, well, negative 8 minus 5 is negative 13a. I want to have a all by itself, just like before. At this point, I need to divide by what is attached to that variable, divide by negative 13, and my final answer will be a is equal to c over negative 13. It may look ugly, but that's the actual answer to this problem. Okay, so we're going to solve another problem. This particular problem says 7h plus f equals 2h plus g, and we're solving for g. Well, the first question I've got to ask myself is, where is g in this problem? Okay, so g is right there. Is there any other g's in this problem? No. So I'm going to go ahead and figure out what else is on the same side with g. This 2h is, and that's it. Well, I can move this 2h to the other side simply by negating it, doing minus 2h. Minus 2h. There is an h over there, so that's nice. We're going to draw our line. Draw our wall, as your middle school teachers called it. And I could write it out like this, or I can combine like terms at this moment. Point is, I've got a g on this right side all by itself. And then I have 7h minus 2h, which this time I could write it as 5h, or I could write it. I still have that plus f. And there is my final answer. That's it. Nothing more to this problem. So this problem's a little more tricky. So they gave me k plus m over negative 7 is equal to n, and they want me to solve for k. So my first thing is, I'm going to write this like this. K plus m over negative 7 is equal to n over 1. And I write it that way because this is a problem where I'm going to want to use my cross multiplication skills, which I always circle to know what I'm cross multiplying. So I'm going to multiply the 1 times k plus m and set that equal to the negative 7 times n. So then my next step, well, 1 times k plus m is simply k plus m, and negative 7 times n is negative 7n. Well, now again, I'm solving for k, so I want to move everything to the other side. There's only the m that I need to move, so I'm going to subtract it since it's positive. Now it's going to look a little different, so I'm left with k over here. Over here, I have a negative 7n minus m. I cannot combine those. That would be the answer because m and n are different. So that would be the answer to solving for k. Okay, so in this problem, they're giving us q equals p parentheses r plus s, and they want us to solve for p. This, even though what you have here looks way uglier, this is no different than a problem like y equals 3x. Okay, no different. It's just there's a lot more to it. So if I want to solve for p, I want to move everything to the other side that's not there. Well, fortunately, I have a multiplication right now. So I have p times r plus s. So to get rid of it, to make p by itself, I can just divide both sides by that r plus s. When I do that, yes, I'm left with p on the right side, q over r plus s. And that is my answer. That's it. So the problem this time says 4m minus 3n equals 8, and they want us to solve for m. So again, the first question I always ask is, what side of the equation is the letter that we're solving for on? Well, m is right here, so it's on my left side. So I'm going to go ahead and draw the wall, draw that wall. I want to move then anything that's not attached to that m first. Well, I can move this 3n to the other side. To move it, I'm going to add 3n because I'm doing the opposite. I'm left with a 4m on this left side. Now on this right side, I cannot combine the 8 plus 3n. They are different. They are not the same. They are not like terms, so I can't combine them. My next step and final step is I want m to be by itself. Right now I have 4 times m, so I'm going to divide everything by a 4. Once I do that, I'm left with m over here. 8 divided by 4 is actually clean, so I can make that a 2. And then this, you can write like this. You could have kept it the same, but this would be your final answer. So this problem says 15 equals 3n plus 6p, and they want us to solve for n. Okay, so again, I asked myself, the first question is always the same. Which side, left or right, of the equal sign is the letter that they're asking me to solve for? Well, in this case, they want me to solve for n. I see an n right here, and that's the only place I see an n. So I'm going to draw the wall. I know now that the n is right here. So I want to move anything that's not attached to that n first. So I have a plus sign, I have a 6p, so I'm going to move it by saying minus 6p, because I want to get rid of that on that side, minus 6p. Now, on the right side, I have 3n. On the left side, I have 15 minus 6p. I cannot combine those. They are not like terms. I have a 16 and I have a minus 6p. Can't combine them. So now I want to get n all by itself. Well, right now I currently have a 3 times n. So the opposite of multiplication is division. So I'm going to divide everything by 3. Now notice I'm dividing everything by 3, not just certain things. I divided both of these items by 3. And then I'm left with an n on the right side. And I simply have, I can do this math. 15 divided by 3 is 5. Minus 6 divided by 3 is 2, and it has the letter P.